Hey everybody, welcome back. We're checking out homework 4.2, and so far we should have done all the way up through number 6, and we're going to be picking up here with number 7. So our questions are going to be on the right hand side, and I'm going to be writing them over here on the left. So we've got a vector r, and it's got x and y components. So these two components are perpendicular to each other because one lies on the x-axis and the other one lies on the y-axis. So the r component of this vector is 14 meters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, Rx equals 14 meters. And the y component is negative 9.5 meters. So I'm going to go down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and a half right there, negative 9, oops. Let's see, r, y equals negative 9.5 meters. And we want to find the direction of vector r. Well, that means that vector r is the resultant, we call it, of rx and ry. So that's vector r right there. And I can see I'm going to need to move this up a little bit. So let's just... Uh-oh. Don't want to do that. There we go. Sorry about that. Now, remember, this is all... Oh, I should line it up right there. This is all number 7. So this is going to be all pertaining to question number 7. And so the question is, what's the direction of vector r? Well, that means this right here. We measure our vectors based off of the x-axis. So this angle in here, theta, is what we want to find out. Well, let's go about solving for theta. This angle theta right here has, we know two sides of this triangle, and the two sides are the opposite of theta, as ry right here is the opposite. So ry equals opposite. And Rx is our adjacent. Rx is adjacent right there. Theta is what we don't know, and we want to solve for theta. Well, we do have values for the opposite and the adjacent. The opposite being negative 9.5 meters, and the adjacent being 14 meters. And we'll think about it for a minute. What sine function involves the O and the A? Remember our SOHCAHTOA? That would be tangent, right? Tangent of an angle, the angle we're trying to find, as a matter of fact, equals the opposite, which is negative 9.5, over the adjacent, which is 14. Now, it should be noted that when we're doing this, when we're solving for an angle, we always want to get a positive angle. Now, you might say, well, wait a minute, that angle's below the x-axis, right? Yeah, true, it is in a negative direction, but we want to solve for the absolute value of the angle and then describe what direction it's going in. So when we get that, we want to solve for the absolute value of the side. So even though ry is negative 9.5, the absolute value of that is 9.5 over the absolute value of 14, of course, which is 14. And again, if you missed this part in class, I'll refresh you in just a minute here. But so we're told here that the tangent of the angle we're looking for is 9.5 over 14. But we want the angle itself. We don't care about the tangent of it. We want the angle. So what is it? And I don't know why that keeps popping up, but sorry about that. So what is it? Well, if we want the angle itself, that means we need to take the inverse tangent, tan to the negative 1, or usually it's your function button and then the tan button on your calculator, of that times 9.5 over 14. If we take the inverse tangent of 9.5 over 14, that will give us our angle. Now again, your calculator needs to be in degree mode, not radian mode, but that'll give us our angle in Well, honestly, whatever mode you're in, but we want degrees. So what is the inverse tangent of 9.5 over 14? That should be about 34 degrees. 34 degrees. So I'll just tentatively box that off because that's kind of our answer, but the direction not only involves the degree that it is, but off of what axis it is. Well, we have, let's look up here, our R vector is below what would be the positive x-axis. If this is, so we make our origin right here. This, of course, would be positive x, and we showed right here that this is negative y going down. That's negative y. So that's a positive x-axis, and our vector is 34 degrees below it, below the positive x-axis. So that's what we're going to write as our final answer. Theta, let me change back to red here. Theta equals 34 degrees below the positive x-axis. We could also state it as being 34 degrees south of east. If we look at our coordinate system, if this is north, south, east, west, here is east over here, and 34 degrees south of it would be that right there, 34 degrees. So you can state it that way as well, but whatever way you're comfortable with, this is our final answer, 34 degrees. And we accounted for the fact that it is going in kind of a negative direction by simply describing it 34 degrees below the negative x, or below the positive x-axis, not above it. That would be different. So that's our answer for part A right here. I'm gonna, let's see, I'm gonna erase this so I have a little more room to write. And all this was part A. Now I kind of took my good old time getting around to that, but that's part A. Let's do part B right here. What's the magnitude of the vector? Well, this should actually be relatively easy to determine because we have two of the sides. If Rx equals 14 and Ry equals negative 9.5, then R, being the hypotenuse, should be the square root of Rx squared plus Ry squared. And you might be asking, well, where did that come from? Well, if you recall, the Pythagorean Theorem, Pythagorean is c squared equals a squared plus b squared. That means the hypotenuse is the square of the two sides squared and then added together. Well, if we want to solve just for the hypotenuse, or in this case, we want to solve just for the vector r, we take the square root of both sides. So this simply comes c equals the square root of a squared plus b squared. And that's essentially what we just wrote right up here, but we wrote it with respect to r. So let's figure it out. R, our vector r, the value of our vector r, is the square root of Rx, that's 14 squared, plus negative 9.5 squared. Of course, the negative part doesn't really even matter because if you square it, it becomes positive. So R, if we square them, add them together, take the square root of the whole thing, R is going to come out to be, our answer being 17 meters. Of course, if we round. All right, so that's part B right there. And our final part is, so we did A and we did B. What would happen if we doubled Rx and Ry? That is, what if Rx was 28 and Ry was negative 19? Well, the answers to A and B would change, or at least one of them would. What would happen in part A? Well, if we doubled Rx and Ry, all it would do is simply double the size of the triangle proportionately. which means that the angles wouldn't change at all. It would simply just be bigger. And sorry that keeps popping up. So that means that the angle theta would be no change at all. It would still be, well, whatever that angle, 34 degrees. It would still be 34 degrees, just in a larger triangle. But the difference with B would be that R would double. If the magnitude of the sides all double, then the size of R has to double as well. Everything gets bigger all around. So there we have it. That's our question number 7, homework 4.2.